This will be our first video where we are going through some suggested chapter review problems. So the first topic that we're going to review is the first derivative test for increasing and decreasing functions. And we'll just do two problems for them for that topic, number 17 and 18 from the chapter review for chapter 3. S is equal to 12.236 t squared plus 294.92t plus minus 2109.0, and t is between 9 and 13, representing the years 2009 to 2013 inclusive. And this is supposed to be a real model for a real business with their actual sales information. So we want to find if their sales were increasing over this time interval of 2009 to 2013. So we're going to take the first derivative. That becomes 24.472t plus 294.92. We're going to set that equal to 0 to find the critical number. So 24.472t is equal to negative 294.92. And we're going to divide here. T is equal to negative 294.92 divided by 24.472. Negative 294.92 divided by 24.472 is going to be about, I don't need this to be perfect, but about negative 12.05 is good enough for the purposes of this problem to know that it is negative 12, which is far below negative 9 or positive 9 that I'm interested in. So my critical number is down here somewhere, and my interval of interest is up here somewhere. And let's go ahead and stick a number like negative 13 in as a test point here with my calculator. 24.472 times negative 13 plus 294.92 is going to be a negative value. And if I were to stick in a number to the right, like say positive 13 up there, that's going to be positive on this interval here. And the whole interval is positive, so we're decreasing from negative infinity to that number that's about negative 12.05. Let's see if I can change that to a decimal and get something exact, or change it to a fraction and get something exact. No, I can't. Increasing from negative 12.05 to infinity. And the only critical number is t is about negative 12.05. Any t greater than negative 12.05 produces a positive value for S prime, or you can call that ds dt. So the sales are increasing from 2009, t equals 9, to 2013, t equals 13. All right, that's number 17. We'll now look at number 18 in this video. Number 18 is r equals negative 0.0245 t cubed plus 0.8838 t squared minus 10.284 t plus 42.60. And I have that in my calculator already because they want us to graph it to negative 0.0245, and instead of a t cubed, we're using an x cubed plus 0.8838x squared minus 10.284x plus 42.60. And I already looked at this. 9 and 14 is where I want my graph to be. So I'm going to pull this out 0 to 20 so that I can just exaggerate this a little bit more and see that low point and high point right there is what I am interested in. So I'm going to use my second calc and my minimum feature here to find this minimum value. Just cut out a little interval with that minimum that is somewhere right about there. And that is at 9.63474408 something, and I'm going to come here and take that x value and say vars, y vars function y1 of that x that was just there, and get the corresponding y value that goes with it, 3.63710179. See that the x value was what we were just looking at. Now I'm going to calculate that maximum here. And it is, let's just come here to make it bigger. It's 14.18550304. And let's come back to here to say that I want to find the y value that goes with that is 4.626109 446. If I didn't show you the window before that I was using, 0 to 20, with an X scale of 1, negative 10 to 10 with an Y scale of 1, just gave me this nice shape right here to look at. And I looked at that ahead of time so that I could show that to you and get these points. So that was part A, was to use the calculator to get those points. And now we want to use calculus to get those points instead. So part B, R prime is going to be negative 0.0245 times 3 is negative 0.0735 t squared plus 0.8838 times 2 is 1.7676 t minus 10.284 all by itself. And I'm going to set that equal to 0. And because I don't know any better way to do this, I'm going to use the quadratic formula, but I'd like my a value to be positive. So I'm going to multiply through by -1, which doesn't change my zeros at all. And t is going to be equal to a negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And let's go ahead and T1 is about, and alpha y equals n over d 1.7676. Let's do minus first. The square root of 1.7676 squared minus 4 times 0.0735 times 10.284 all over 2 times 0.0735, and we get the left-hand side answer here. T is 9.86334748, just like I have up here. Same number. And if I go ahead and stick that into my original function here, same way that I did with my calculator, let's call that x for a second, then vars, y vars, function y1 at x is going to be 3.63710179. T2 is going to be, let's come back up here and grab this function and change this from a minus sign to a plus sign. Remember, there's a plus or minus in the quadratic formula. We just need to change that one sign to get our other value. And we get 14.18550518, just like we got 0. So it's a little different because we got it from the quadratic formula instead of from the graph, but that's okay. It's basically the same as this here. And we're going to now vars. Oh, let's store that as our x value now, and vars y vars function y1 at x. We're going to see the calculator gave us a very good estimate here using the graph. See, same y value there. So there you have it. And let's just do our first derivative test with those t values here to show increasing and decreasing intervals for the revenue. So we have 9.86, and I'm just going to put ... there. Actually, I'll just call this, since you have the numbers up there, I'll call that T1, and I'll call this T2 on my number line. So picking something less than T1, like 0, will give me this positive value over here. And then if I stick in something like, let's see, between 9 and 14, let's go with 10. So when I do that, this sign will change here and become negative. And when I stick in something bigger than 14, like 15, then, and let me actually stick these values in here for you. Second table, we have 0, and then 10, and then 15. And you can see the sign pattern. Let me stick R prime in there instead of R. That is into R prime is negative 0.0735x squared plus 1.7676x minus 10.284. And I'm looking at the table values for y2 here that are negative, positive, negative. Because I divided through by that -1 up there, I would have had to change these signs, but I went back to the original to stick them in. Be careful with that you don't look at a simplified version here where you already did some work and got rid of a negative sign, or factor the negative out. If you want to do that, this might be safer for you to factor out a -1 like this, and remember that negative is there. It won't change your answers for your zeros. Okay, so this is decreasing, increasing, decreasing. So we're going to say that this is decreasing on the interval from, and I'll call that negative infinity to T1, and you can actually use the number in place of that, union, and then T2 to infinity. And again, you can use the number in place of that, and it's increasing between T1 and T2. And again, you can use your decimal approximations for those there. All right, that will be it for this video. We'll come back next time and we will start maximizing and minimizing functions using the same test where we are decreasing and then increasing. There's a local minimum, where we're increasing and then decreasing. There's a local maximum. So we'll come back and look for minimum cost, minimum average cost, maximum revenue, and maximum profit when we come back next time. See you for the next video.